Dear students, today we see about the infrared spectroscopy. In this unit or the chapter, some important point is kinds of transitions. So these are the various types of the transitions in IR spectroscopy. So in kinds of transition, electrons in a molecule can be classified into the four different types. Closed shell electrons that are not involved in the bonding. These have very high excitation energies and do not contribute to absorptions in the visible or the ultraviolet regions. So it is the first types of the molecules or the electrons in the molecules are the present. Then second, covalent single bond electrons, it may be the sigma electrons. These also possess too high and excitation energies to contribute to the absorption of visible or the ultraviolet radiations. Example, single valence bonds in saturated hydrocarbons, that is in ethane, that is CH2, it is attached with CH2, it is a second type. Then third, paired non-bonding other cell electrons, that is EN electrons, such as those on nitrogen, oxygen, sulfur and the halogens. So these electrons, outer shell electrons, are present on the atoms, that is the nitrogen, oxygen, sulfur and the halogens. These are less highly held than the sigma electrons and can be excited by the visible or the UV radiations. Then the fourth and the last types of the electrons in the molecules is present, there is electrons in the pi orbitals, for example in the double or the triple bonds. These are the most readily excited and are responsible for majority of visible and the UV visible absorptions. Electrons reside in orbitals. A molecule also possesses normally the unoccupied orbitals called antibonding orbitals. These orbitals to excited state energy levels and are either sigma star or the pi star orbitals. Hence, absorption of radiation result in the electronic transitions to an antibonding orbital. The most common transitions are from pi or the n orbitals to the antibonding pi star orbitals, and these are represented as pi to pi star and n to pi star transitions, indicating a transitions to an excited pi star state. The non-bonding n electrons can also be promoted at a very short wavelength to an antibonding sigma star state, n to sigma star. This occurs at the wavelengths less than 200 nanometers. So these are the different kinds of the transitions or the different types of the electrons are the present in the molecule. Around the atom, when one atom is attached to the another atom with the different types of the bonds. So these bonds nothing but these are the pair of electrons. So these electrons are the excited to the excited states with electromagnetic radiations depending upon the strength of these bond or the electrons present surrounding to the atoms or the on the atoms, and there is a different types of the transitions are happen.